Now we're going to be learning what we call the law of sides. We're going to be working on this 4 questions, but let me come to the side. So somewhere on your notes, you should be able to write this. I'm going to give you guys 3 ratios that are equal to each other. So 3 fractions that are equal to each other. First of all, we're going to look at a triangle, not necessarily a right triangle. So I'm just going to draw a triangle here. And let me label my 3 angles. Let me call them A, B, C. Now for angles, I use capital letters. So I'm gonna call this angle A, angle B, and angle C. And then let me label my 3 sides. I'm also gonna label them A, B, C. But for sides, I'm gonna use lowercase letter. Now I see angle A. Angle A is right here. The side opposite from angle A is what I'm going to call side A. Notice how side A does not cross angle A. Notice that. And then I'm going to see angle B. Opposite from angle B, I'm going to call this side B. Notice how side B does not cross angle B. And the same thing, I'm going to call this side C. It's opposite from angle C. Notice how side C does not cross angle C. So again, for angles, I went capital letters. For sides, I went lowercase letters. Now, the 3 fractions that we're going to look, remember ratio is fancy word for fractions, that 3 fractions that are equal to each other are going to be side A over sine of angle A. Notice how I use the same letter, lowercase and uppercase, to emphasize side and angle. It's going to be equal to side B over sine of angle B. And this is going to be equal to side C over sine of angle C. Now, I said there's 3 fractions that are equal to each other. In reality, you only need 2. Which 2? Depending on the information that I give you. Now, another way I can look at these fractions, because we learned last week a trick. I can flip all my fractions and everything is okay. So that means that I can also say sine of angle A divided by side A is equal to sine of angle B divided by side B, which is equal to sine of angle C divided by side C. Notice I just flipped my fractions. Now, which one am I going to use? Depends on the information that I get. If I want the unknown, whatever I'm solving, I want it to be on top. So if I'm solving for a side, I'm going to use these 3 fractions on the top. If I'm solving for an angle, well, I'm going to use these 3 fractions at the bottom. So again, depending on what I'm solving. Okay, so let's take a look at number 21. It says find AB. Find, when I use 2 letters, basically I mean a side. So now I see the side AB. Isn't this what we usually call side C? Because it's opposite from angle C. So I'm solving for a side. Well, guess what? I am going to use when the side is on top. I want the unknown to be on top. But one more thing. I know the 3 angles of a triangle add up to 180. I know one angle is 19, angle B is 19, and one angle is 128. Now, sometimes we're like, well, which one is 128? Is it angle A or is it angle C? Well, think about it. Let's see. Angle A, when I look at angle A, looks pretty small. It looks less than 90. So it cannot be angle A then. In this case, angle C is 128. Now, I can solve for angle A because I know that 3 angles add up to 180. So I add the 2 numbers that I have, 128 plus 19, and subtract it from 180. So I'm gonna find out that angle A is 33. You guys might be like, why is 128 right there? Because it didn't fit at the corner. It just didn't fit at the corner. So we put it there. I solved that angle A is 33. I might use angle A. I might not use it. For sure, I have to, because I'm solving for side C, I have to use C over sine of C. I know angle C, so that's good. What else do I know? I know angle B, but do we know side B? For us to see, I know angle B is 19, but do I know how big is side B? No. In that case, I'm not going to use that. Instead, I'm going to say this is equal to side A over sine of angle A. Oh man, good thing I solved for angle A earlier because now I have it. So let's see what I have now. Side C, I have no idea what it is. I'm solving for it. Over sine of 128 degrees. I can type in on my calculator sine of 128. It gives me a decimal. That's easy to solve. This is equal to 20 divided by sine of 33. Okay. Now I want C by itself. Keep in mind that there's three numbers that I know. 20, that's a number that I know. Sine of 33. So not just 33, sine of 33. It is a decimal. Like I said, we type in on our calculator sine of 33, we will see that it is a decimal. So all of this together. And then sine of 128, all of it is together. So let me get rid of the fraction here on the left. I want C by itself. So I'm just going to multiply this. Let me use red. I'm going to multiply both sides. So if you want to, let me make a fraction. Let me multiply both sides by sine of 128. Notice how I extended my fractions and I put sine of 128 on top of both fractions because I want these to cancel out. So I know that C is equal to 20 times sine of 128 divided by sine of 33. Okay, now just type that on a calculator and you should be good. Let me bring the calculator that I give you guys in Canvas. Let me bring out the calculator here. So this is the calculator. Remember, I mentioned last week, remember to change your calculator to degrees. I see on radians. So let me click on that. So I see degrees. I need to have this in degrees. And then I'm just going to type in what we had. I had 20 times sine of 128. So I'm going to type in sine 128. Make sure you close your parentheses. This case, it is very, very important. I know last week I mentioned most of the time you can get away with not closing your parentheses, but get used to closing them. This time you cannot get away. Like it's going to give you a whole different answer. So I have 20 times sine of 128, close parentheses, right? Divided by sine of 33, close parentheses. And it gives me that number. Now on my instructions, it says rounded to the nearest tenth. So that's basically rounded to the nearest one decimal place. So I'm gonna call this 28.9. Okay, let me come back here. So side C is 28.9. And remember, you just need to type in the number so you're good. Okay, that was not bad. Let's take a look. Question part B. Okay, there's 1/3 angle I can solve. I see angle A is 91, angle C is 61. I'm gonna say angle B is 28. Wait a minute, how did he get that, Mr. Leonzo? add the two angles that I have, 91 plus 61, and subtract that from 180. So that's how I got 28. Okay, that's how I got it. So let's see, what am I solving? Side BC. So look, if I connect corner B with corner C, this is the side that is usually called side A because it is opposite from angle A. So I'm just going to say, I'm going to use side A over sine A. That's for sure because I'm solving for side A equals, okay, I know angle B, but I don't know side B. I know angle C and I know side C. So yeah, I'm going to use side C over sine of angle C. In other words, I have A, so I don't know what that is, because remember, this is my side B and this is my side C. So I have A over sine of 91. It is equal to 28 over sine of 61. Mr. Leonzo, we did not use angle B. Remember how I said in the previous question, I'm going to solve for my angle, my missing angle, just in case I need it. Okay, I didn't use it, but it doesn't affect me having that angle. Okay, so I'm going to say that, let me extend my fractions here. I'm going to multiply both sides by sine of 91. Because then this cancels out. So I have that A, it is equal to 28 times sine of 91 divided by sine of 61. Do not cancel the signs. Sine of 91 is a whole thing, so you cannot break it apart. Instead, multiply this. So let me multiply this out. I'm going to grab my calculator. So let me go 28 times sine of 91, close parentheses, divided by sine of 61. I do have it on degrees, so that's good. It says 32.00. Rounded to one decimal place. So I'm going to say this is 32.0. So A is equal to 32.0. You might be, Lorenzo, can I just type in 32? Because 32 is the same thing as 32.0. Yeah, in this case, we can. The previous question, you had to write it as a decimal, right? 28.9, we had no choice. When the decimal is 0.0, I guess you can choose. Now, we know how to solve for a side. What if I ask you to solve for an angle? Here I want to know how big is angle C. I only know angle A. Remember how in the previous two questions, I gave you two angles. And I said, well, having two angles, you can figure the measurement of the third angle. Now I did not, because otherwise it would be too easy, right? When I'm asking for an angle, it will be too easy. So I'm just going to give you one side. So let me see what I have. Let me label my side. Let me see what I have. I have angle A for sure. And then I have side A. Good. I'm solving for angle C. A good thing I have side C. Good thing. Now from angle B and side B, I have no idea. So let me label what I have. And I remembered, I gave you guys the formula that sine of angle C over side C is equal to sine of angle A divided by A. Notice how, because I'm solving for an angle, I have that sine on the top. So when I'm solving for an angle, I'm using, remember when I mentioned the ratios earlier? When I'm solving for an angle, I want sine on the top. When I'm solving for a side, I want sine at the bottom. Okay, so now let's take a look at here again. So what do I have? I have the sine of angle C divided by 15 is equal to sine of 77 divided by 20. If I extend my fractions here and I multiply both sides by 15, because I want these 15s to cancel out, I'm gonna get that sine of C is equal to, okay, let me figure what that is. Sine of 77 times 15 all divided by 20. Let me grab my calculator again. So I have sine of 77, close parentheses, times 15, times 15 divided by 20. And it gives me a big decimal. I'm not quite done yet. Notice how, let me come back here. I know that sine of C was equal to 0.730778. Now, you can say, well, let me round that to one decimal place. So 0.7. You type it in and it is wrong. I want to know what angle C is, not what sine of C is. So there's still one more step I have to do. I remember last week that I told you guys, when we know the sine of an angle, I can solve for an angle. I can say C is equal to, but when you're going to bring sine to the other side, you're going to call it sine inverse. So remember, I'm going to go sine inverse of 0.730778. So this is what I had to figure out. Okay, so let's get back to my calculator. I don't see sine inverse. So remember, you had to press this second, and then you see it. So I press sine inverse. I know here it says a sine. I mentioned last week, so this is nothing new. We call it sine inverse. Some people call it arc sine. The calculator's making sure it covers both cases. We can call it sine inverse or we can call it arc sine. Same thing. So, okay, so let me type my decimal that I had. I had 0.730778. Close parentheses and press enter. So 46.95. Okay, so I know the 5 is going to push the 9 over. Don't call this 46.10 because 46.10 is the same thing as 46.1. So you're not rounding up, you're dropping it, you're rounding way down. So I know the 5 is going to push the 9 over, but because the 9 is at the limit, the 9 is going to push the 6 over. So see that? The 5 pushes the 9, but because the 9 is at the limit, it ends up pushing the 6. So my answer should be 47.0. Let me come back here. So my angle C is 47.0. Again, 0.0 is optional. You write it as just 47. Fine. Okay. Lastly, let's take a look at angle A. I only gave you one angle. And is this angle B or is it angle C? I see angle B because I know a 90 degrees, an L shape is 90 degrees. So 73 should be less than an L shape. In this case, that's angle B. And I know that I gave you side B and I gave you side A. Because side A is opposite from angle A. And I'm asking to solve for angle A. Find the measurement of angle A. Okay, so I'm going to use the law of sine. So I'm going to say sine of A over side A. Because I'm solving for an angle, I want sine on the top. And I'm going to say this is equal to sine of angle B divided by side B. When I replace the values that I know, I have sine of A, because I have no idea how big is angle A. I'm solving for it, divided by 5, because side A is 5. This is equal to sine of 73 divided by 23. Let me extend my fractions and let me multiply by 5. I'm going to multiply both sides by 5 because I want this 5 to cancel out. So that gives me that sine of A is sine of 73. Remember, this is whole thing. Don't forget the parentheses. Times 5 divided by 23. Okay, so let's take a look. Let me grab my calculator. I want sine, not sine inverse. So let me click my second again. So I'm going to go sine of 73, close parentheses, times 5 divided by 23. So sine of 8 is 0.2892 and some more. Okay. So I'm just going to round this. Let's just call this 0.207892. I know my answer. Eventually I have to go to the nearest tenth. So 6 decimal places is fine. Now, angle A, for me to solve for angle A, I'm going to say it is sine inverse. Because remember, when I'm moving sine to the other side, make sure you switch it to sine inverse of 0.207892. So let me come back to my calculator here. And now I want sine inverse. So I go second now. Sine inverse of 0.207892. Press equal 11.99. Okay. So the second 9 pushes the first 9, but it's at the limit, so it ends up pushing the 1. So I'm going to call this 12.0. So angle A is 12.0, or just 12, because the 0.0 is optional. Remember your law of sines.